Welcome to the E-Academy. In today's episode, we will continue with the topic of building automation in the KNX standard. In the previous episode, there was a brief introduction to the KNX system itself, and we shortly described what functions the system can offer. We also showed which KNX devices are produced by SATEL. Okay, in this episode I will give some information on KNX systems and present a few issues that will be relevant during programming. To start with, is it worth recalling one of the main distinguishing features of an automation system built in this standard? Namely, that it is a decentralized system. There is no main unit, such as a control panel or controller that manages the operation of the whole system. The individual devices communicate with each other via so-called telegrams. When it comes to exchange of data between the individual devices, we can speak of four media and their associated communication protocols. These are respectively Twisted Pair and KNX TP protocol, TP from Twisted Pair, Low Voltage Wiring and KNX PL protocol, PL from Power Line, Wireless Radio Line and KNX RF protocol, RF from Radio Frequency, and Ethernet and KNX IP protocol. The one that is most commonly used in practice is Twisted Pair TP. This is also the one we will focus on now and use in coming episodes of the E-Academy. In the case of a KNX TP installation, all the system devices communicate with each other over the bus. The devices that are connected to it can be divided into two main types, sensors and actuators. Sensors are the devices that receive signals from the outside. These can be, for example, simple buttons, switches, various parameters sensors, and multifunctional panels. Actuators, on the other hand, are various types of controllers that often manage the operation of numerous devices, switching, dimming, or roller shutter actuators, etc. In addition to these, the installation requires at least one power supply, but about that in a moment. As far as the bus cable is concerned, it is in the form of a 4-core cable, two pairs of wires with a diameter of 0.8 mm. The two main wires insulations are in red and black to make them easy to identify and avoid confusion when connecting to the KNX device connectors. As a reminder, the connectors are precisely in red and black colors. The other two wires in white and yellow insulation are spare ones. They are sometimes used, for example, to connect the power supply to modules, using 24 volts DC. Both pairs are twisted together and housed in a metallic shield. The color of such cable, outer insulation, is green. This makes the bus cables easier to find in the clutter of building installations. Certified cables are marked with the KNX logo. As I mentioned earlier, one of the necessary components of any KNX TP system is the power supply. The output voltage of KNX power supplies is 30 volts DC, while devices on the network can be supplied with a voltage from the range of 21 to 30 volts DC. Such a wide range makes it possible to compensate for possible voltage drops on the wires. There are many different power supplies available on the market, differing in output current. For example, our KNX PS640 power supply features an output current of 640 mA. Of course, the number of devices that can be powered by a single power supply depends on the individual power consumption of each device. When necessary, it is possible to connect more power supplies to the line, although this is subject to certain restrictions as well as manufacturers' recommendations. However, due to the detailed nature of this information, we will not discuss it now. It is worth adding that, in order for the smooth operation of the system, the length of the cable between a single bus device and the power supply must not exceed 350 meters. In turn, the cable length between two bus devices must not be longer than 700 meters. As for the maximum length of a single line, this can be up to 1,000 meters. On the other hand, the minimum distance between two power supply units working in one line should be 200 meters, unless otherwise specified by the manufacturer. In addition to power supplies, another essential device in an installation is the choke. A large proportion of commercially available power supplies, like the KNX PS640 mentioned before, have such a choke built in. There is no need to install a separate device. It should be mentioned here that the data transmitted over the bus is in the form of AC voltage and is superimposed on DC supply voltage. If there were no chokes, the power supply circuit would attempt to continuously correct the voltage changes associated with the transmitted signals, which would adversely affect the performance of the system. Okay, I will now turn to a brief description of the KNX TP system topology. The basic unit of a KNX installation is the line. Up to 256 devices, i.e. sensors and actuators, and a minimum of one power supply can be installed in such one line. Within a single line, for example, a tree topology can be built, with branches at arbitrary points. This saves on cabling compared to a star system. It should be added that a ring structure is not used in KNX installations. One remark here, the information on the maximum number of devices in a line applies to installations set up after 2018. Prior to this year, no more than 64 devices could operate in one line segment. This number could be increased by means of special line repeaters. At that time, the main line segment could be extended by 3 more. The line repeaters had to be subtracted from the total number of devices in the line. Of course, additional power supplies had to be added there too. Okay, so this is what it was like until 2018. As I said a moment ago, currently 256 bus devices can operate in one line. The number seems to be sufficient to automate a fairly large single-family house. For example, a small office or guest house. However, a situation may arise where even more devices are needed when designing the installation. Well, further lines can be connected to the main line. So-called line couplers are used for this. The structure created in this way, containing the main line and no more than 15 secondary lines coupled to it, is called an area. A maximum of 255 devices can be installed in each of the secondary lines. The primary line, on the other hand, can have one more device, in total 256. However, the number of all line couplers operating in an area must be deducted. The maximum number of these is 15. To sum up, a total of up to more than 4,000 bus devices can be installed in a single area. In addition, separate power supplies are supplied for each line, both main and secondary. Moving on, what about the situation of very complex KNX installations intended to operate, for example, in a large office building, a public building, or a large hotel? Obviously, it will become necessary to extend the structure. How can this be done? Backbone couplers can be installed on a so-called backbone line, with which up to 15 areas can be connected to it. In addition, up to 256 devices, including couplers, can operate on a backbone line, as on the previously discussed lines. This line, of course, also requires its own power supply. As a result, more than 61,000 devices can be installed across the entire KNX TP network. It is worth adding that such a topology has several advantages. Firstly, the couplers provide galvanic isolation between areas and lines, which protects them in the event of an overvoltage, for example. In addition, all lines, including backbone and main lines for individual areas, have their own power supply. Consequently, the failure of one power supply unit will not cause the entire network to stop working. The rest of the system will continue to operate without interruption, excluding, of course, those functions that were carried out in the idle part of the installation. In order to uniquely identify the individual devices in a KNX TP installation, each device must be given an address. But we will talk about it in the next episode. That's all for now. Thank you, and see you in the upcoming eAcademy episodes. Until then.